How are you, grade 10 learners? Welcome to our first lesson for term 3. I really hope you are happy to join us for this live lesson. Okay, are you ready for the lesson, grade 10s? I really hope so. Right, today, grade 10s, we're going to look at the equation of a straight line. But before we do that, let me introduce myself. I am Sikhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are going to learn about the equation of a straight line today, grade 10s, and I want you to be ready for the lesson. So make sure that you have your book there with you, your pen, your ruler, and your pencil. Please look for those things now before we start. We are going to sketch the straight line function, and then after that, we're going to look at the equation of the straight lines. Okay, so make sure you have those things with you so that when we start our lesson, you won't be moving around wasting time. Okay, right, and feel free to ask questions. We are waiting for your questions. Please don't hesitate to send your questions. If there's something you don't understand, 079 454 That's the number you use, okay? And then you are going to send your questions. Maybe moving fast, you don't understand something, please send us your input, okay? Right, I really hope that everyone is ready now. Let's just start our lesson. Right, by the end of the lesson, learners, you'll be able to investigate the effect of A and Q on the graphs defined by y is equals to A times f of x plus q, where f of x is equals to x. So basically what we can say here, we can replace this f of x with x and say this is the graph of y is equals to ax plus q. That's what we're going to be looking at today. This is the function y is equals to ax plus q. Right, we're going to find the equations of a straight line or the linear function. Okay, these functions have names. So the straight line function is called what? The linear function. And then we're going to interpret straight line functions. Okay, right. Now our pre-knowledge, we're going to use our knowledge about linear functions, our knowledge about substitution, then the function concept, and also we're going to use our knowledge about simultaneous equations. Now I want us to try this activity. There's question 1 and question 2. Okay, maybe some of you are not familiar with this, but I'll try to explain and assist you, and then you try. Don't worry if you don't know it. We're going to discuss soon after that. So soon after you've tried. Now let's go to question 1 and question 2. We're going to do question 1, and then after that we're going to do question 2. Okay, right, let's go to question 1. It says sketch the graph of f of x is equals to 3x using the gradient and intercept method. What do I mean by that? Using the gradient and intercept method. Right, check the function there, f of x. What is the y-intercept? And then you check the function there, what is the gradient? And then after that, you use that y-intercept and you use the gradient to sketch the graph. Okay, let's try that for 3 minutes. Let's try. Right, welcome back, grade 10s. Did you manage? Okay, don't worry if you didn't get it. Let me try to explain this for you. Right, remember we're looking at which function? We're saying for y is equals to ax plus q. Do you remember this function? In some books, you may find this function written in this form. Y is equals to mx plus c. Okay, do you remember that? So m is equivalent to a, and then the q is equivalent to the c. Right, what is q? What is q? You can give the answer there verbally in the classroom. You don't need to write it down. Right, what is q? You can say the answer in the classroom. Q is the y-intercept. Q is the y-intercept. Remember that. And then what is A? Which is equivalent to M there. What is A? A is the gradient. Do you remember the gradient? Remember the gradient is vertical change over the horizontal change. Do you remember that? Okay, change in y over change in x. That's the gradient, right? And then q is the y-intercept. Now we have this function. Remember, f of x and y is the same thing. We have the function f of x is equal to 3x, and then the q is not appearing there. So what does that mean? It means our q is 0. You see that? It's like the q is 0. So it means what is our y-intercept? Our y-intercept is 0. So we're going to put a dot on 0 there. Right, now we have 1 point. We need another point. We need another point, grade 10. So what do? We have to use our gradient. We can use our gradient now. What is our gradient? Gradient, we said a is the gradient. So what is a here? This is the 3. The gradient is 3. So the gradient is equal to 3. And then if the gradient is equal to 3, it means it's 3 over 1. Meaning that the vertical change is 3, and then the horizontal change is 1. Okay, if I count 3 times going up, I must count once going to the right, because the gradient is positive if you check, so I must go to the right. So I will count 3 times going up, 1, 2, 3, that's the vertical change. And then I say 1 going to the right, that's the horizontal change. You see that? And then we'll have a point, and then when we have the 2 points, we can now join them. We have sketched the graph. Do you see that? Let's do this together. So let's count. Check the scaling there. It's very important for you to see. So 0 to 1, 1, 2, 3. That's vertical change. We have moved up by 3 units. Now, this is vertical change. 3 vertical change. Okay, we're going to be using gradient today, and then this is horizontal change. Change in x. Okay, right, and then we count once, and then we put our point there. You see that? Now we have our 2 points, then we sketch our graph. Okay, I'm going to give you 1 minute to just sketch the graph, and then we're going to move on to the second question. Okay, let's try that 1 minute, and then we move on to the second question. Right, welcome back, grade 10s. I really hope you managed to copy the graph there. Let me emphasize again. What did you say the Q is? Q is the y-intercept. And then what did you say the A is? A is the gradient. Please remember that. Okay? Q is the y-intercept, and then A is the gradient. Remember that, okay? Don't forget that. Now, our gradient here, if you check here, our A is equals to 3, or we're saying that the gradient is greater than 0. The gradient is positive. So if the gradient is positive, what do you see there? What can you say about the graph? Is the graph an increasing graph or decreasing graph? It is increasing. Do you see that as the x values increase, the graph is going up? So the graph is increasing graph. So if A is greater than 0, if A is positive, the straight line graph is increasing. Okay, right. Let's move on to the next one. Now I want you to use the dual intercept method. What does dual mean? Dual means what? Two, okay? Two. So two intercepts. Which intercepts are we talking about here? The x-intercept and the y-intercept. I want us to start by finding the x-intercept for 2 minutes, then we move on to the y-intercept for another 2 minutes, then we sketch our graph. Let's find the x-intercept, and then after that we're going to find the y-intercept. For 2 minutes, find the x-intercept, the coordinates of the x-intercept. Let's try. Right, welcome back. Did you manage to find the x-intercept? What does x-intercept mean? Where the graph intercepts the x-axis, where the graph cuts the x-axis, isn't it? And then what do we know about the x-axis? We know that y is equals to 0. Along the x-axis, y is equals to 0. Okay? Right, now, so to find the x-intercept, where there is y, we put 0. Okay, right, let's just do that. So now this is our equation, and then do you see that our equation was what? H of x is equals to negative 3x plus 6. I want you to take note. We talked about the q. In this case, our q is 6. We talked about the a. In this case, our a is negative 3. Okay, we want to see the effect of these two parameters. Right, now I was saying where there's h of x, remember h of x is just y. Y is equal to negative 3x plus 6. So it means where there's y, we put 0. That's why we have the 0 here. And then we are solving for x. We know how to solve what? Linear equations, isn't it? Now we can transpose the negative 3x, and then it becomes 3x is equals to 6. And then what do we do next? Divide by 2 on both sides of the equation, we get that x is equals to 2. Then what are the coordinates of the x-intercept? It's going to be 2, 0. Remember the ordered pair. We start with the x followed by the y. Okay, if y is 0, x is 2. So our coordinates for the x-intercept is 2, 0. Okay, 2 for x, 0 for y. And then we plot it there. Okay, right. And then, okay, we move on to the y-intercept. I'm going to give you 2 minutes again for what? For you to find the y-intercept. Now plot your points. You don't need to draw a complicated Cartesian plane. Just the x-axis, the y-axis, and the x-axis is fine. Then we're just sketching, isn't it? We're just sketching. And then let's go to the y-intercept. For 2 minutes, find the y-intercept. Right? Well done, Cretans. Well done. Well done. Now, let's see. Let me just give you the solution. Now, y-intercept x is equal to 0. Remember we said here y is equal to 0 along the x-axis, but along the y-axis, x is equal to 0. Remember that. So that's why when we're finding the y-intercept, where there's x, we put 0. So you see that where there's x, we put 0 there, and then what we get? We're getting that y is equal to 6. Do you see that? Y is equal to 6. If x is 0, y is 6. So we can write the intercept like this. Do you see this? Do you see the Q there? Do you see the y-intercept there? You see that? So Q represents the y-intercept. So we plot our point there, and then we sketch our graph. Do you see that? Okay, we have our graph now. What is the gradient of this graph? It is -3. What can you say about a negative gradient? Do we get an increasing graph or a decreasing graph? It is a decreasing graph. Decreasing graph. If A is negative, the graph will be decreasing graph. Remember we had our graph which was like this. Which was like this. It was f of x is equal to 3x. It was an increasing graph. This one was increasing. And then this one is h of x is equals to -3 plus 6. It's decreasing. When the gradient is negative, the graph is decreasing. Okay, right. I think we've covered everything. Now let's go to the main part of our lesson. Learners, remember our WhatsApp line. We haven't received any communication from you. It's 079-454-9535. That's the WhatsApp line you have to use. Okay, right. Now, if you have questions, please send us those questions. Now, we want to find the equation of a straight line. Now we know how to sketch, or we've revised how to sketch a straight line. Now, let's say you are given an equation or a linear function. If you are given a linear function, how do you find the equation? I'm going to show you several methods, okay? But the first situation, you may be given a y-intercept and one other point that lies on the line. You may be given a y-intercept and one other point on the line. Or you may be given any 2 points which lie on the line. So these are the two situations I want us to look at. Okay? So I will give you an example for the first situation, and then after that I'll give you an activity to do. Okay? Right. We agree, isn't it? Right. I'll give you an example, then we go to the what? To the activity. Okay, even during the example, you have to be participating. You can say your answers there in the classroom. You can be doing writing on your book instead of waiting for me. Okay, right now, let's look at this situation. What are we given here? We are given a y-intercept, which is point A, and another point which is on the line, which is point B. So the other point must be on the line. And then now, how do we find such an equation? What do we do? Okay, let me try to guide you here. So, what did you say about the y-intercept? Which parameter is it? The y-intercept is our q, isn't it? So, I will write that. F of x is equals to ax plus q. In this case, our y-intercept is 9. You see that? Okay, and then I will substitute the other point which is on the line, which is B. If you check here for B, x is 3 and y is 6. Be careful, don't substitute where there's y you put 3 and then where there's x you put 6. No, don't do that. Your y is 6. Remember, ordered pair is x and y. So your y is 6 and your x is 3. So you say 6. Let me erase this. It's going to disturb my... Okay, let me just erase that. Then we go back. It's fine now. Let me see. Okay. Right. Is it writing? Oh, no, it's not writing. My pen now has disappeared. What is happening? Perfect. Right. Now, I was saying we will substitute f of x. We put 6 is equals to a, and then where there's x, we put 3, and then plus 9. You see that? Now, then we can find our a. You see that? I have that there. This step here is this step there. Okay? And then let's simplify that. How did I get my negative 3? Because I said 6 plus 3, 6 is equals to, this is equals to 3a plus 9. Then you transpose the 9, comes this side, becomes 6 minus 9. And 6 minus 9 is negative 3. Okay? And then what do we do to get a? We divide both sides by 3. And then what do we get? We get negative 1. So our a is negative 1. So where there's a here, this one, we write negative 1. Do you see that? Then we have our equation. You see, we have our equation. What is the y-intercept? It's 9, 0, 9, the coordinates. And then what is the gradient? Negative 1. Do you see the graph is decreasing? Sometimes when you do this, learners, you have to check if your answer makes sense or not. We cannot get an a value which is positive for a graph which is decreasing. Check that. These concepts, you're going to use them for all functions. For all functions. We have done those functions, the parabola, the hyperbola, and all those things. You cannot get an a which is negative while the graph is concave up. You can't. You cannot get an a which is negative, positive when the graph is concave down. In this case, also for linear functions, we cannot get an a which is positive when the graph is decreasing. Our a must be negative. If our a is positive, our graph must be increasing. You see that? Please check that. So these concepts are going to be used in all the functions. How you find your x-intercept, how you find your y-intercept, how you find the equation of the function. It's the same thing. Okay? Right. Now, we have done the first part. Let's go to the activity. Are you going to try it? You have to try. Let's go to the activity. Enjoy. I'm going to give you 3 minutes. Let's try. Welcome back, grade 10s. Yeah, we got a good question. We're yet to get the name of the school. When we get the name of the school, we're going to acknowledge that. And then now the question is, do we get to choose the point to substitute for this situation? Okay, right, we have point A, as I'm going to be explaining. Okay, let me explain this and then I'll explain that. I'm going to answer that question. The question was, should we choose the point to substitute? Okay, so let's do the question together, then I'll cover that part. Right, so now f of x is equals to ax plus 8. Where's the 8 coming from? Should be 3. Okay, right, f of x is equals to, okay, yeah, that was a mistake. So it means f of x is equals to ax plus 3. Where is the 3 coming from? That's the y-intercept. So we've used the point A. We have used point A. Now to substitute, so that we can get the coefficient of x, we have to use the other point. So we can't use point A for finding Q and use it again to find A, isn't it? To find the coefficient of x. So we have to use point A for the value of Q, And then to get the coefficient of x, we have to use the other point. Okay, I think I've answered that question. So now use the point, for the intercept for q, and use the other point to find the coefficient of x. Okay, so now we have substituted, like here we substitute this point. Our y is -1, and then our x is 8. So it's going to be 8a plus 3. And then we can bring 3 this side. Okay, it's called transposing. Then it becomes -1 minus 3, which is -4. And then we divide both sides by 8 to get our a. We get that a is -1/2. Again, it's a decreasing graph if you check, and our a must be negative. And then what's the equation of our graph? Where there's a, we write -1/2, isn't it? We write -1/2. We have our equation. We have our equation. Do you see that? Okay. So now this is what we do when we are given a y-intercept and another point on the line. Let's go to the second situation. Right, the second situation, right, we'll be given 2 points, and I'm going to show you 2 methods. The first method that I'm going to show you is using the gradient, and then the second method is using the simultaneous equations. So this is what we're going to do. I'll give you an example. We do the 2 methods together, and then I give you an activity. On the activity, you will choose the method that you want to use. Okay, you won't do both. You'll choose the method that you're comfortable with. Okay, are we fine with that? Perfect. Let's move on. Please send us your WhatsApp questions or your input or 079 454 9535. Okay, let's move on to the second situation. You may be given any 2 points which lie on the line. The points must be where? On the function, on the line. Determine the equation of the straight line passing through the points a is equal to the coordinates of a being 4 and for x and 4 for y, and then the coordinates of b being 6 for x and 8 for y. If you check here, we can't find our q here because we don't know the y-intercept, isn't it? So what do? Right, we can start by finding what? The gradient. Do you remember the gradient? Change in y over change in x. So here I can draw this maybe to remind you. Our y changed from 4 to 8. From 4 to 8. And then our x changed from 4 to 6. You see that? So how do we get the gradient? We have the gradient formula, which is like this. So yb, which is 8, and then minus ya, which is 4, over xb, which is 6, minus xa, which is 4. I want you to try for 30 seconds. I'm not going to go anywhere. I'm going to wait for you. 30 seconds. Substitute your y coordinate for b and your y coordinate for a, and then substitute your x coordinate of b and x coordinate of a into this and find the gradient just for 30 seconds. Let's try that. Right, I really hope you've managed to do it. Now let's substitute. You see that it's going to be 8 minus 4 over 6 minus 4, which is 4 over 2, and then it's 2. Do you see the graph is increasing? And our gradient is positive. Do you see that? And then now we have our gradient. So it means we can write our equation and say f of x is equals to 2x plus q. Okay, we have the gradient now, which is 2. Now, how do we find the q? How do you find q? What do you think? Now you can substitute any of the points. You can substitute any of the points. You can substitute A, you can substitute B. You'll get the same answer. Okay? If you want to try to be ahead of me here, you can try that. Substitute A and substitute B. Choose one. Choose one. Don't do both of them. But I'll do both of them here so that you can see. Just try to be ahead of me. Right. Let's substitute A. If I substitute A, you see that we have this. Where there's Y, we put 4. Where there's X, we put 4. You see that? And then we solve for Q. So it's going to be 4 is equals to 8 plus Q. And then we transpose the 8. Let me just write it. 4 is equals to 8 plus Q. Then we transpose the 8, becomes 4 minus 8, which is negative 4. And then it means the Q there is negative 4. Okay, let me just leave it there. And then now I'm substituting this one. Where there's Y, I put 8. Where there's X, I put 6. And then becomes 8 minus 12. What is 8 minus 12? It's still negative 4. Do you see that we're getting the same answer? So it means here the Y coordinate here is going to be 0, negative 4. Because Q is the represented by the y-intercept. Okay, right, that's the equation. Done. And then there's a second method that is using simultaneous equations. Simultaneous equations. This is very, very important for you to understand. Right, we can create equation 1 using point A and equation 2 using point B, and then we solve the equation simultaneously. Okay, right, now you have to know your simultaneous equations. We can solve simultaneous equation by substitution, by elimination, and even equating. But I'm going to use substitution. Okay, right. Now, let's create equation 1. Remember, our equation is f of x is equals to ax plus q. You see that? So, we are going to substitute. Where there's x, we'll put 4. Where there's y, we put 4. And then we have something like this. And then this is our equation number 1. Okay, copy that. Copy equation 1. You can copy equation 1, then we move on. Equation 1, copying, you're copying. Try to be fast so that we can finish what we've planned. And then, can we go to equation 2? We're going to use point B to create equation 2. So where there's x, we put 6. Where there's y, we put 8. And then, so we see that where there's y, we put 8. Where there's x, we put 6. Okay. And then now we have equation 2. Now we have 2 linear equations that can be solved using elimination, or that can be solved using substitution. How do we do substitution? Okay, let me give you time to copy equation 2. You can just copy equation 2 so that we can move fast. Copy equation 2 first. 8 is equals to 6a plus q. Right. And then let's create equation 3. Do you remember substitution? You have to create the third equation. Okay, let's create equation 3. We have to isolate one variable. Let's isolate q here. Remember, we did literal equations. Let's apply our knowledge about literal equations. So now we isolate q. So we just brought 6a to this side. It becomes 8 minus 6a is equals to q. And then we can be written like that. Q is equals to 8 minus 6a. That's equation 3. And then what do we do with these 3 equations? We have equation 1, equation 2, and equation 3. So where there's q, we created equation 3 using equation 2, isn't it? Now, where there's q in equation 1, we have to put this 8 minus 6a. So we're going to replace this with 8 minus 6a, and then we can solve for a there. Okay, like this. Okay, you see that? We have replaced q with 8 minus 6a. Now we need to solve for a. We need to solve for a, learners. Okay, you can try to be ahead. Okay, time is moving, but I'm trying to be slow so that you can understand at least. It's okay. I hope you've managed to copy and trying to be ahead of me, trying to solve for a. Try to solve for a. And then Now I've removed the bracket. There's an invisible one here, and the invisible one does not change anything in the bracket. You see that? And then we can collect our like terms. Remember how we solve linear equations? The variables on one side, the constants on one other side. Okay, it's unlike the quadratic trinomials where one side must be 0. Okay, but linear equations, one side must be the terms with variables, and then the other side must be constants, the numbers without the variables. Then like this, you see? And then like we moved 4 minus 6a is negative 2a, and then we move it to the left, it becomes positive 2a, and then when 4 comes this side, becomes 8 minus 4, which is 4. Then we divide by 2 on both sides, a is equals to 2. Do you see that? Okay, a is equals to 2. And then now we have our a, we can find our q. We can use any of the equations. Do you know that? But I'll just prefer this one because it's already q is equals to. Okay, q is equals to. So it's going to be q is equals to 8 minus 6 times 2. You see that? And then so it's going to be q is equals to negative 4 because it's going to be 8 minus 12. Even if I use this, I'll get the same answer. Let me just show you. 4 is equals to 4 times 2 plus q. You see that? Okay. And then what is 4 times 2 is 8. So it's going to be 4 minus 8 is equal to q. So minus 4, negative 4 is equal to q. You see, you're getting the same answer. Any of the three equations will give you the same thing. Okay? Right. Now, we're done. Okay, so let's write the equation. We have our a, we have our q. What is the equation? What is the equation? Remember, our equation is, let me write it here, f of x is equal to ax plus q. So a is 2, and then q is negative 4. So the equation is going to be f of x is equal to 2x minus 4. Right. Okay. Right. I wanted to give you an activity for the for this particular method, but let's discuss it because of time. We're left with 15 minutes. I'll try to move slowly. I'll try to move slowly so that maybe you can cover more things. I wanted you to try it, but let's do it together and try to be ahead of me. Now you have an idea, isn't it? I'll be asking you to do things ahead of me, and then I'll just immediately give you the solution. Okay, let's move on to the second one. It was supposed to be an activity, but let's do it together. Right. Determine the equation of the straight line passing through the points A. Can you see that? Negative 4 and negative 5, and then B, 3, 9. What do we do? We have to, let's start with the first method, gradient method. Let's find our gradient. Let's find our gradient. This is the gradient formula. Let me write it for you. Find the gradient for 30 seconds. Right, I hope you managed to find your gradient. Let's see. What did you substitute? YB, the y coordinate of B is 3. The y coordinate of A is negative 5. So it's 3 minus negative 5. What is it? It's going to be 3 plus 5, isn't it? Negative minus negative becomes positive. And then the x coordinate of B is 9. The x coordinate of B is negative 4. X coordinate of A is negative 4. So it's going to be 9 minus negative 4. So it's going to be like this. You see that? Okay. So it's, I made a mistake somewhere. What did I say? Let me say it again. Yeah. I said the y coordinate of B, let me highlight it. Y coordinate of B is 3. Y coordinate of B is 9. I'm making mistakes here. The y coordinate of B is 9. The y coordinate of A is negative 5, isn't it? I'm making mistakes. Say is making mistakes. So y coordinate of B is 9. Y coordinate of A is negative 5. So it's going to be 9 minus negative 5. And then the x-coordinate of B is 3. Then the x-coordinate of A is -4. So it's going to be 3 minus -4. Okay, very sorry for that, learners. I don't want to confuse you. I think it's clear now, okay? Yeah, I don't want you to be confused. Clear? Is it clear? Everything? Perfect, perfect. And then now, so it's going to be 14/7, where A is equals to 2. A is equals to 2. And then now we have our gradient. So what do we do next? How do we find our Q? So we now know that f of x is equal to 2x plus q. Now we can substitute any of the points there. We can substitute A, we can substitute B, and then we're going to get our Q. Do you see that? So we can substitute A or B there. Okay, let's start by substituting A. Where there's y, we put -5. Where there's x, we put -4. You see that? We have our y here, our x there. And then we solve for q. Okay, does it make sense? Now, let's see. So it's going to be -5. How did I get that? Let me show you here. -5 is equals to -8 plus q. And then we transpose, becomes -5 plus 8 is equals to q. Okay, you see that? And then -5 plus 8 is 3. So our equation is going to be, oh, okay, let's use this point first. Let's use this point and see if we are going to get this answer. So it's going to be 9 for y and 3 for x. And are we getting the same answer? Yes, we're getting the same answer. Okay, so the equation now is f of x is equals to 2x plus 3. Done. We found the equation. And then the next method is finding this using the simultaneous equations. Okay, so create two equations and solve simultaneously. What did we say? We have our equation f of x is equals to ax plus q. So what do? We substitute the first point, then we substitute the second point. We create two equations. Can you try to create these two equations in 1 minute? Let's try for 1 minute. Let's try to create the two equations. Right, welcome back, learners. Thank you very much. That question that I talked about, where someone asked us, like, how do we substitute? Do we substitute the two points or any of the 2 points? It was from Harrisburg State School. Thank you very much for that question. I really hope that it helped you, and the answer also could have helped someone also with the same problem. Okay, thank you very much for that. Now, let me try to show you the two equations. Let's substitute the first point, which is A. I started with B here. So it means where there's Y, we put 9. Don't worry, if you started with the A, it's still okay. It's fine. We're going to get the same answer. So where there's X, we put 3. Where there's Y, we put 9. And then it's going to be like this. And then we have our equation 1. So it can be equation 2 for you. It's still okay. Okay? That order does not matter. And then we come to this one, we substitute our -4 and -5. So where there's y, we put -5, where there's x, we put -4, right? And then we have something like this. Do you have these two equations? Okay. Now let's create equation 3. Even if you create equation 3 with equation 1, it's still okay. At the end, we must get the same answers. Okay? you must get the same answer. So take these things as what? As the guidelines, and then you can do your own thing according to your equations. But answers must be the same. And then Q is equals to -5 plus 4a. I've made Q the subject by moving -4 to the left hand side. So it's -5 plus 4a like that. And then where there's Q in my equation, I'll say my equation because my equation 1 may be your equation 2. In my equation 1, I will replace Q with -5 plus 4a. And then I solve for what? I solve for a, okay? I solve for a like that. So I will do this with my pen. My pen is not moving. Okay. Okay. Let's just take a 1 minute break. We'll come back. 1 minute break, then we'll come back. Let me just fix my pen. Okay.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great. Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
Welcome back, learners. I'm just from the shops. My pen, it ran out of ink. I'm back with a new one. Okay, thank you for waiting. Right now, we're saying what? Okay, we say that we have our equation f of x is equals to ax plus q, and then I'm now lost, but okay, we had found our what? Okay, we need to find our a here. We are going to substitute this into this equation. Equation 3 into equation 1. Equation 3 into equation 1. Do you see that? Okay, we're going to do that, and then let's just do that. You see that? I'm going to put this thing, I'm going to put it here, and then now we solve for a. We solve for a. Let's solve for a. And then I hope that when you're waiting for my pen there, I managed to do something ahead of me. And then now there's an invisible one here which does not change anything. Let's transpose. If you bring this one this side, it's going to be what? 9 plus 5, which is 14, isn't it? What is 3a plus 4a? Is 7a, isn't it? So we have 7a is equals to 14, or 14 is equals to 7a. And then what do? We divide both sides by 7. We get that a is equals to 2. And then you can substitute a into any of these. I'll prefer this one because it's already saying q is equals to. But you can substitute equation 1 or equation 2, we'll get the same answer. Let's put our a here and see what we're getting. We're getting q is equals to -5 plus 4 times 2. What do we get? We are getting 3. And then we're saying the equation now is going to be f of x is equal to 2x plus 3. We've managed to find the equation. Okay, right. What did you learn, grade 10s? We learned about the Q. We learned about A, that Q is the y-intercept, that A is the gradient for this equation, f of x is equal to ax plus q. And then if A is positive, the graph is increasing. If A is negative, the graph is decreasing. We learned how to find the equation of a linear function. We may be given a y-intercept and another point. Okay, that one is easy because we know that the y-intercept is the q. And then the other one may be given any 2 points on the line. Then now you can choose if you want to use the gradient method or using the simultaneous equations. Okay, right. Now let's just try. I had more questions, but because of time, we could not do them. Let me just explain what you're supposed to do when you get such questions. Okay, I'll just go through them and then you can do them later. If you can take a picture, I know that some people cannot manage to take pictures, but if you can take a picture, you can do that, and then you are going to use what I'm going to tell you later in your during your spare time. Okay, right. The question was like this: if you can take a picture, please do so, and then maybe you can share with friends and all those things so that everyone hears this question. Then what I'll do, I'll just quickly go through the what you're supposed to do. Okay, what you're supposed to do. Then you can do it later, and then even we can go to memo, say there, and try to get clarity on the things. Okay, let's just do that. Take a picture if you can. Okay, if you can, and then we move on. I'll just explain A, B, C, D, E very fast, and then we end our lesson after that. Okay, right. Now, I'm not going to go through the information because of time. So, the first question says, find the coordinates of C. If you are finding the coordinates of points that are given, ask yourself, what is this point? So, if you check C here is what? Is the y-intercept of f. Again, identify the function. It is the y-intercept of f. So, how do we find the y-intercept? X is equals to 0. Don't forget that. So where there's x for this function, put 0 there, and then you'll find your y coordinate there. Okay, or the coordinates of C. Okay, right. The second one was we're finding the coordinates of D. Right, what is D? What is D? D is the x-intercept of G. So how do we find the x-intercept? Where there's y, we put 0. So we're going to put 0 here, and then you solve for x. Okay? You're going to put 0 there and solve for x. And then the next one was A. What is A? A is a point of intersection. And then at the point of intersection, the two functions are equal. So just say 3x minus 4 is equals to 2x minus 5. And then you solve for your x. You will get the x coordinate, and then you substitute your x coordinate into any of these two functions to find the y coordinate. Okay, right. And then we had this question, where is g of x greater than 0? If you check here, the graph is equal to 0 here because y is equal to 0 there, but it's greater than 0 where there's a red arrow there, and then less than 0 below the x-axis. Greater than means, is it above the x-axis or below? Greater than means above the x-axis. Less than means below the x-axis. And then you get this x-intercept here. It means the graph is greater than 0 when x is greater than this x-intercept that we have here. Let's say the x-intercept was 2,5. Okay, let's say it's 2,5. For x greater than 2,5. I've given a clue. Your x must be 2,5. If you're finding the coordinates of D, you must get 2,5. Right. Okay. We're going to do more of these questions or these concepts later, but let me just give you highlights. These are like highlights. Okay. We're going to do this interpretation of graphs. We have a lesson for this, so don't stress. And then this one, where is f of x greater than g of x? You are comparing the two functions. So at this point here, they are equal. And then to the left of the dotted line that I've drawn, you can see that g of x is above f of x. So g of x is greater than f of x. And then to the right, going this side, you can see that f of x is above g of x, okay? I know that the last question here is just highlights, okay? You may be confused, but you have an idea. When we're going to have this lesson in the future, you're going to understand, okay? You're going to understand. I'm going to take my time on this. And then, thank you very much for joining us for this lesson, grade 10s. Enjoy the rest of your day. We are going to meet next week for our other lesson. Goodbye.